Hello and welcome back to the Hyperthesis. We are in the episode 42 plus 1, so 43. The topic is going to be quite appropriate, I think, because we have a bunch of forest fire in Canada right now, and so going to be discussing that for today. My name is Feely.
I'm Patrick.
And I'm Lee.
All right, so we are back. I think all topics today are going to be related to climate and things on this earth that we have. So for the intro topic today, I write to raise this topic of investigation into Earth climate in the past. And one thing people do is to drill into the Earth's surface, that's ice, or the glacier, and to try to figure out what happened in the past. So how they do it is they go to very cold place, or like the poles, for example, and they drill into the ice that's been formed over many like millions of years or thousands to millions of years. So what happened there was that the water from the ocean, which has certain composition at the time of minerals and life and bacteria or single cell organisms, would not fly it up, but evaporates and got with the wind carry it to the poles, and it snow, and it keeps snowing for many years, especially during the ice age. Technically, I think we're still in the ice age, but the snow falls down to the ground and keep falling down, so they compressed the snow under it until it became ice. Well, snow is already ice, but a different type of ice also and keep accumulating. So over millions of years, we have this really thick ice. However, if you drill the ice and bring it up, you can see layers and layer of change between temperature change because the structure to be different of ice and the composition of minerals and such. So you can tell if the Earth was warmer, if what kind of organisms were around to tell the history from this glacier.
Yeah, this is a really cool topic. I'm very fortunate that there's the Canadian Ice Core Lab at the University of Alberta, which is like a world-class ice core research facility. And the really neat thing that I want to add is that when snow falls, it has air trapped in it. And then as more snow falls on top, that air gets trapped. You actually have these tiny little gas bubbles that are representative of the atmosphere within these glaciers. And so we can trace things like carbon dioxide amounts, and we can see a whole bunch of things that were going on based on layers within the ice. And the really neat thing is that we have layers that are many kilometers deep. And so we can see very, very far into the past. Now, mind you, it's only tens of thousands of years and not millions and millions of years, like if we drill into rocks, because we haven't always been in an ice age. We go through ice age cycles. But for this ice age, at least, we can fairly accurately tell what the climate was like and what the atmosphere composition was like, and even what the ocean composition was like based on these tiny little bubbles.
Well, actually, there's 2.7 million years old ice that the University of Princeton dug out. Oh, I'm just reading this from one of the magazines I just got for the physics magazine, and it's called the Codex Plan. And so they found a 2.7 million year old ice. So that is pretty impressive. And when they dig them out, they call them ice core, and they send to storage around the world. I think in the U.S., the prominent one is in Denver, Colorado. So yeah, there's people research on it, even though it's not as old as rocks, and I believe it might be easier to deal with than try to analyze rocks, right? Because at least you can melt it, or is well, let's say radiation is easy to pass through ice than rocks, and so you can analyze things with X-rays or other methods that I could be wrong for X-ray, but you can imagine try to do some type of diffraction or things to figure out structures.
I think they can even tell, like, with pretty like, in those little bubbles, right, they can say, like, "Oh, this particular few hundred to 1,000 years was, like, a really" they can tell out, like, specific details that are pretty I guess you wouldn't think they would. They'd be like, "Oh, there was a little bit more CO2 in the air during this time," or something like that, or other elements as well. Not it's pretty cool, actually.
I do just also want to highlight, so the person who runs the Canadian Ice Core Lab here is Dr. Alison Crisitiello. Sorry if I mispronounced that. Um, but some of the oldest ice is actually found just in the north here on Mount Logan, which is Canada's highest point. And it does contain some of the oldest ice in the world as well, because it's instead of being an ice cap, which can fluctuate, or an ice sheet, such as on the North Pole, this is at a very high altitude. So it's more likely to stay there and move less and go through less melting. So they're doing active research where they have to essentially climb a mountain with a whole bunch of equipment to get these very old ice cores. But it's just incredibly, incredibly cool stuff.
Yeah, the problem is trying to get very old ice is that sometimes they are very deep. And the problem is really very deep is the geothermal heat would melt the ice and it's gone. So I think they dig up down to like three kilometers or something like that. And like 3,600 meters to find like 400,000-year-old ice. But they say if they dig deeper, the ice gone because they melt. So it's really hard, but I think some postdoc found like very old ice site somewhere, so they changed some plans, and that's pretty cool.
How much do you guys know about the drilling equipment they use? Because, I mean, if you've never heard of this before, you might imagine they dig like a really, really deep mine shaft or something, but that's not what they do. They just have this little cylindrical drill that's like, I don't know how big it is, but it's got to be like a foot or less. Not, you tell me.
Yeah, it's so
Like
um
wide, I
I'm
mean.
a, I'm looking at a picture of it right now, but yeah, it's only a couple inches wide.
Oh,
So I
okay.
think like maybe 4 or 6 inches wide, but it has to be very carefully done because you don't want to disturb the ice core or break it or anything. But you still need to drill it out. So it's a coring bit. And again, it has to go kilometers down. So it's a very
Long,
interesting piece of
very
equipment.
long, thin tube.
It says like it takes 5 years and $50 million to drill like a deep ice core. So
Wow.
yeah, it's longer than some people's PhD. It's like, all right, here's my PhD. I'm gonna go drill this ice. 5 years later, I got my data, boys.
And I also just want to say the weight of this because it is ice, which can be pretty heavy. So in the case of this mission that was sent to Mount Logan, first of all, they had a 900-pound ice core drill, which is incredibly heavy to haul up a mountain. And then they were drilling for 14 hours every single day. So working in about 3 hour shift, just because you're at a high altitude, you don't want people to become tired. And then running for 14 hours a day for 11 days, pausing only once to repair the piece of equipment, they were able to extract a 2,000-pound ice core. So that's a lot.
I was reading a story where they had to be really careful because once they lost a drill, they dug deep and somehow the cable broke. They lost drill, so they have to find another drill, another borehole, and they lost 2 years of work.
I will say, if you want to find out more about what's under the ice and um, how we're studying it in different ways, you can check out our episode. I believe it was episode 37 from last season, where we had Zoe Vesterman, who did some work up in the north, working with some different ice people to try and see what was under the ice without having to take ice cores.
All right. So yeah, that was good. I was thinking like, oh, we started with ice, so we can talk about fire. So it's like the episode of Ice and Fire or Song of Ice and Fire. Sounds familiar to someone, anyone? But but it's like I think it's original book that the Game of Thrones is shows based on, right? Well, anyways, let's move on to the main topic: fire, wildfires, and you know, for the past couple weeks, a week. Also, we have heard about a lot of wildfires in Canada, from Alberta, BC to Nova Scotia, that's been affecting a lot of people. And I actually heard more from the Alberta side all the time. A few years ago, we had a huge fire at the Fort McMurray, all the stuff. And Patrick, I think, is from Fort McMurray too, so he probably knows a lot more about how to live with smog. is to me, fire is not as bad as the smoke that come out of it, right? Is because smoke can affect many more people, and it's created a condition where it's really hard to breathe and all this stuff. Because the fire itself usually don't spread to the city, but the smoke, that is the issue.
Yeah, assuming you have people trying to stop the fire from spreading, and fighting it, you can kind of outrun it. You can pick your stuff up and move, which sucks. Obviously, you leave a bunch of things behind. Maybe your house gets burnt down. That's awful. But at least you're not being trapped in it. Whereas like the smoke, it's the air you breathe, right? You can't really outrun it that easily.
Yeah, so like you can fight fire with fire too, which is really like a neat concept, right? You just like burned out all the fuel, oxygen in certain place strategically, and also the wildfire would just run out of fuel. That's pretty cool.
Yeah, and we'll certainly talk more about that. Just to comment on the smoke, just a couple weeks ago, Edmonton and other parts of Alberta had the worst air quality index in the world, aside from like a couple cities, I think in India and China, where they have very intense smog, but it was like going out and there was a sepia filter over everything where you could barely see like 100 meters in front of you. And it was very red and orange and very all-consuming smoke. And that came from a forest fire that was hundreds of kilometers from the city. So it certainly has long-range effects. And the fires themselves also have a big impact. But we've also seen our smoke from Canada travel all the way to Europe and other places in the world. So it's very interesting to see how the smoke travels. But today we're going to focus more on the source of the smoke. Of course, there are many health issues and many fun, but also not fun problems that arise from trying to model where the smoke will go, and model how the wind will flow and all of that. But today we're going to be focusing on fires themselves. And wildfire is the generic term for these types of wildfires. However, it depends on geography of what you call them. In a country like Canada, where we have a lot of forest, but we also have a lot of grasslands, we'll call them forest fires or grass fires. Whereas in a place like Australia, which also experiences quite a few forest fires, I believe the end of 2019-2020 was a very large forest fire along the eastern coast that devastated a lot, that was quickly overshadowed by a global pandemic. But in Australia, they call them bushfires. There are many other names, such as a hill fire, a desert fire. You can have peat fires, so in dried out bogs. But they are all wildfires. So for a wildfire to start, we need some certain conditions.
From time to time, I like to look on the NASA website. There's actually a fire map. So they have the satellite data. You can look really pretty easy, right, from the infrared signal that they give where the fire is. And you can tell, especially from a tropical country, in just wild forests, like just, no humans, for example, they just so many little fire everywhere. So it's not uncommon to have wildfire. What uncommon about these huge wildfires? Fires, they're just so massive, right? Which also naturally occurring sometimes, right? And it's a way that the forests refresh their nutrients or their material to create carbon, for example.
Just to highlight that website, so this is something that's actually used in research, but it is the NASA FIRMS website, which uses some different types of remote sensing satellites to show where hotspots are. So it will definitely show where wildfires are, and if it's a notable wildfire, it will be marked, but it can also show where hotspots are. So if you look, say, around areas that have a lot of industrial productivity, you can see hotspots there too, because chances are there's some hot processes going on, whether it's a power plant or in Edmonton, we have a lot of oil refineries, so you can see where hotspots are, but it's great for mapping forest fires and other types of wildfires.
Yeah, I'm looking at it right now, and I was about to say, surely this can't be forest fires, because like a third of Mexico would be on fire if it was just maps of forest fires. So it's also just like hotspots in areas that are very toasty, I think.
Well, you got to zoom in. It's not as clustered as you think.
Oh yeah, it's definitely not as clustered. Like I'm looking at the. We'll come to this because again, right now there's some wildfires in Nova Scotia happening, which is where I'm from, and kind of where Patrick's from, I guess, a little bit. But when I zoom in on it, yeah, it looks like when you look at the hotspots, there's like very little points in Nova Scotia, so you think like, oh, there's clearly like no big forest fires happening there. But turns out the Earth is a big place, so a small little dot can be a huge area.
Yeah, so in Nova Scotia and in Alberta and possibly in Mexico, one might suspect that if there's a forest fire going on, it's probably going to be quite dry. I know we've seen a lot more droughts recently in recent years, and droughts produce excellent conditions for wildfires to start. Now, if you remember learning in school about the fire triangle, or the three necessary components of a fire, you have your fuel, oxygen, and heat. So you need all three of those for a fire to exist, and if you take one of those away, then the fire will be put out. So for example, when you dump water on fire, that takes away heat, and you're no longer producing heat, and that puts the fire out. And water is able to absorb quite a lot of heat, so that's why it's so effective. Now, when it's very wet in a forest or in a grassland or any vegetative area, that water is able to absorb a lot of the heat and essentially protect whatever vegetation is there. However, when there's not a lot of rain, things will either die off because they're dehydrated, or some types of trees and other plants will actually be able to store water and conserve it by losing their leaves or drawing the water out of leaves and essentially killing off the leaves in order to survive. So we see that happen a lot in Canada in winter, where the temperature changes, it becomes drier, there's snow on the ground, and all the trees lose their leaves. And the leaves go through senescence, where they change color, all the chlorophyll is pulled out, and then they dry up and drop off. And this helps save the tree. So in drought conditions, other trees can do this. However, it makes things very desirable for starting a fire. And so I think in a future episode, we'll discuss how trees work, because it's really fascinating how they can do this type of thing. But in essence, all these leaves dying and these plants dying during droughts will produce a lot of fuel. And of course, there's already a lot of oxygen in the atmosphere that can feed the flame. So all we need is heat. So to start a forest fire, one of the most common causes for starting a forest fire is actually lightning. So as was mentioned earlier, there are quite a few natural forest fires. In fact, most forest fires happen naturally, or at least the most burned area is caused from natural sources. Primarily lightning. I think in Canada, it's about 44% of all forest fires are caused by lightning. But then we also have other natural effects, such as just the sun reflecting weird and creating a hot spot that then ignites. Think kind of like a magnifying glass.
Caustics.
Darn it. We can never escape them.
Focusing event, my good sir.
Yes. So those can happen naturally, creating hot spots. And then I also heard of an incident where a beaver took down what it thought was a tree, but was actually a power line pole. and caused a wildfire. So I guess that's kind of natural, kind of man-made.
Nature,
Depends how you look
nature's
at
fighting back.
it. But there are other hot sources that can cause wildfires too, and depending on how dry it is, it's easier. So lightning strikes, of course, are very hot. It doesn't need to be too dry for them to start a fire. And other things like cigarette butts, I mean, they're already burning. If you throw them into a very dry area, it will spark immediately. Another large contributor to wildfires that's man-made are vehicles. So if you're driving on a quad or a dirt bike through the forest, it gets very hot, the engine is very hot, and that can actually start fires just by driving over some dry areas. So provided the conditions are right, and in Canada and other places in the world, they seem to be very right for forest fires, it doesn't take much at all for them to start.
Again, just because I'm from Nova Scotia, I'm always gonna talk about Nova Scotia as kind of my base example. But there was a really bad hurricane there, fairly recently. I forget how many months ago it was. It was in October. Yeah, it was in October, and it must have knocked down like half of the trees in the province or something like that. Maybe not quite half, but it was a huge chunk of the trees. Maybe a tenth. I don't know. I'm just guessing. But when you walked around like public parks or even driving on roads, like months and months later, you still just see like every like groupings of trees just collapse. There's too many of them to clean up, knocked over. And I imagine there's going to be even more forest fires in Nova Scotia because there's so many down trees drying out that there's just so much like fuel available for forest fires to start. So might be a rough summer.
Yeah, and that's a thing, is that we'll get into fire prevention and suppression methods shortly, but that's a huge contributor to forest fires, is the fuel that can be provided. So there is a lot of natural death in forests. So trees, especially in the boreal forest, have a lifetime between like 60 and 90 years. So you do see a lot of tree mortality and trees dying, and a lot of, especially in the winter, leaves falling off and then drying out in the spring because they didn't decompose. There's so much fuel, and this fuel helps spread the fire and fuel the fire. A lot of people think that fires just spread through wind, and it does play a very important part, especially higher winds that are able to both spread the flames themselves and spread the ash, which might be hot, and can ignite other pieces of forest. And wind can help carry forest fires or other types of fires over roads or rivers. In the Fort McMurray fire that was mentioned a little bit ago, that wasn't expected to jump about a kilometer-wide river, but it did quite easily because of very high winds. But the fuel that we see is another contributor to wildfire spreading.
Also, the wind refresh the oxygen, right? I think when anyone who learned how to make a fire, they were like, you blow on it, you blow on it, you blow on the hot ember, right? Because you want to stoke the fire. I think that's the word. And you want to push more oxygen into it, even though like our breath, like when it comes out, has less oxygen because we use oxygen. Still enough that to induce, like to fan the flame, basically. I think it was called. Yeah, so enough to fan the flame. You can actually use a fan to fan the flame. It's pretty fun thing to do, but just don't do it too much in the wild.
Yeah, and it's interesting because fires create their own weather. It's so hot that hot air rises, of course. Cold, oxygenated air comes rushing in, and we can even get phenomena like fire tornadoes, where you have this just intense amount of wind and cyclonic activity that a tornado forms with the fire. They look terrifying. I think I've seen one in person, from a distance, of course, but they are not to be messed with. But going back to fuel and the idea of how fires travel, most fires start usually along the ground. So when conditions aren't extremely dry, or even if they are really dry, most fires will start on the ground. So tends to be a lot of fuel that's on the ground. Like Liam mentioned in Nova Scotia, there's tons of fuel after the hurricane. lots of dead trees that have spent time drying out over the winter and then over a warmer spring. And so the fire will consume these first, especially if it starts on the ground. So the fire will essentially eat away at all this fuel, feeding on it. But this tends to move slower. So ground fires or like just surface fires tend to consume a lot of the leaf litter or fallen trees and branches and dead brush, but they'll move slower because there's quite a lot of fuel and they don't burn too hot, usually below 400 degrees Celsius. Now, if a fire becomes larger, it will start to consume smaller trees and other low-level vegetation that's been dried out. And if the fire keeps growing, then it will start becoming what's known as ladder fire, where it can start to climb up trees, especially the taller trees, and go into the crown.
Well, is the fire temperature just depend on the material, right? It cannot have a very high temperature fire if the fuel cannot like ignite at that temperature. So it's not just about like, to me it's all about the condition of the material, because like if you remember like like fundamental chemistry, you make like some like real elemental fire, right? Like when you pick an element and have the specific color, but that also comes with the specific temperature that's supposed to ignite. Liam would talk about it in terms of black body radiation, of course, but I feel like if you want to have really high temperature fire, then you have to have completely different composition of the elements to make that happen.
We did an episode on fire. I feel like I should mention that. Maybe you did and I just missed it, but I don't remember what episode it is, but we have this whole discussion on fire at one point, so go check that out.
Yeah, it's called Playing with Fire, I think.
Yes. Yeah, I mean, it does depend. I mean, hot fires depend on what's burning, but at the same time, like, I don't know if you've ever stuck your hand in a wood fire, but pretty hot.
And I mean, there are different materials being burned at different stages with fires, and the amount of material that's being burned. So with these very slow-moving fires, they are slow-moving, so it takes a while to burn, say, through a log or through, a fallen tree. Whereas as the fire gets more and more intense, it will get hotter because there's more burning, so there's more heat energy in the system, even though it's an open system. But we'll just say it's more heat energy in the system, and there's a lot more burning and different materials. Because when you transition from a ladder fire to what's known as a crown fire, that's where all the dried leaves in the trees start to catch fire. And if you've ever burned a leaf before that's dry, or even a piece of paper, very similar, it just goes up in a flash. And it's quite hot, again, different material, quite dry, very fast burning, but very hot. And so when these crown fires start, when the fire spreads to the crowns, very dense forests, or even somewhat dense forests, you'll see these fires go from one crown to the other, and they'll spread very, very quickly because leaves burn quite quickly. So they can spread like wildfire, which, yeah. So there are different ways in which it can spread, and it has to do with the amount of fuel that's there. So these raging forest fires that we're having now are because there is a lot of fuel there. And I was actually involved with some work a couple of years ago that was looking at using AI to identify fuel based on drone imagery and drone data. So you could fly over an area, identify where fuel is, or identify where large amounts of fuel are, or where it might be drier based on some reflectance data. And then you could say, okay, these are the areas you need to focus on by either removing trees or removing fuel. And that's something that's being actively done in parts of Alberta, is they're removing like dead logs and other brush from forests to remove that fuel.
Well, if you look at it in a more analytical term, more, you can see a forest as some kind of system where there should be some kind of stable solutions where, there's No, there's like a balance between amount of fuel and fire, right? And there should be amount of trees that should be maintained. But in this system, you can also see there are so many elements. Well, you can so say that maybe some kind of chaotic element to it, where if this fire started a certain place, the solutions would get pushed into unstable orbits where maybe all the fuel would get burned out or the forest would be all gone, right? So I think in a way, fire is like a fluctuating regulator that helps maintain the balance. So there aren't too many trees, but you can also see that maybe there's certain configuration or condition that drive the solution into exterminating all life, right? So into like unstable orbits. This is more like a physicist view or mathematician view, but I think people do this too to analyze like this kind of dynamical system, right? Is in a way it is. Maybe there's so many degrees of freedom, but there's a way to quantify it such that we have better understanding as to why or how should we approach this, how much fire should we induce, like how else are you going to do it, just statistical data? Well, the point of modeling is to help further the understanding of the underlying fundamental issues.
No, I think you hit the nail on the head with that from a kind of analytical perspective, because as you said earlier, forest fires can be good and they are natural. And so you have, I don't know, this kind of metastable state that is dependent on the amount of fuel that's present. And so if the amount of fuel that's present happens and then it's bumped out of the metastable state, it will either be a runaway system or it will damp back down into essentially the fire will put itself out naturally. And so natural forest fires have been around since as long as forest fires have been around. We actually have evidence from about 400 million years ago of charred wood or wood charcoal. So we know that forest fires have been happening essentially as long as plants have been on the earth. And there are actually species that have evolved to work with wildfires. So there are certain types of species. There are a couple of coniferous species that produce cones, and these cones can only be opened in very high temperatures, like those found in a forest fire. And so while the parent tree might be killed, it's actually only able to reproduce through forest fire. And of course, forest fires, when there's not too much fuel present, don't burn as severely or as hot because there's not as much burning. And so they're able to be less severe. They eliminate less life, so things still survive in there. And they tend to be smaller.
I've seen those like documentaries where it's like a forest fire goes through like, I don't know, a forest or a jungle, and then kind of like immediately after you see all these plants like spontaneously just growing out of like the ash. I mean, one other thing is weather can have a big impact. Well, you guys are talking about like wind and stuff, right? But like rain can have huge impacts on it. Can reduce the lifespan of forest fires by so much. Like even if the conditions are really hot and dry and suddenly forest fire starts, there could be a torrential downpour the next day and the fire gets put out. So you can have like little short-term forest fires sometimes if you're lucky, I guess.
I have a whole section written up on that
Right.
that I want to return to.
Jumping the gun.
Oh yeah, but it's good to bring that up. Before we move on to there, though, I do just want to mention, and this is something that I was able to learn about and listen about, but there's actually some indigenous cultures have essentially traditions of burning forests or sections of forests. So these are known as cultural burns. I don't know too much about them. I'm not of indigenous heritage, but I was able to listen to some information about them and read some more information. And essentially this also helps the forest by, say, burning the fuel that's on the ground in a very gentle manner. As gentle as a fire can be, you're able to remove a lot of fuel and it provides nutrients for the forest. It removes that fuel. Other things can grow where there was previously just a whole bunch of dead vegetation on the
Everything
ground.
got like
So these cultural burns.
everything gets like overgrown after a while, right? So it kind of like cleanses it a bit.
Exactly. Yeah. And so it's a part of some indigenous people's culture, which is really cool.
Yeah, I mean, control burns happen all over the world. It's not just indigenous tribes, right? Like some forestry administration actually have the unit for control burns. It's just like we figure out, like, well, to me, the word overgrown is relative. Like, is for us, like we say it's overgrown, but hey, nature has been regulating itself for millions of years, and we are. Things are overgrown. Maybe because for human life, it's gonna be much more difficult if things are quote unquote overgrown, because you know large forest fire, like who cares, right, if there are no humans. Because that's the way they regulate itself in a larger scale, in the way forest regulate itself, even though maybe a very large part of the forest might get burned out, but for the forest it's actually good for them.
So, just to comment on that, the idea of overgrown, yes, it's kind of relative, but from outdated forest management policies, essentially we've let forests become much more overgrown than they will naturally be. So instead of doing controlled burns, or for a while they were prevented, and essentially any kind of fire was bad fire. So what we're seeing is that from these kind of older, outdated policies that didn't really work in the first place, we've seen a lot more buildup and a fuel, especially. So maybe not necessarily overgrown forest, but a larger amount of fuel than what would naturally happen because we've just been suppressing fires instead of preventing them in more natural ways. And so that leads to higher fuel loads, and those higher fuel loads lead to more fires. And while smaller fires are okay, these very hot crown fires that are essentially devastating the landscape actually aren't that healthy.
Yeah, I think you have a good point on fire suppression, right? Because I think, especially in North America, or maybe just Canada, I'm not sure, but like there's fire suppression. In the past has been like a lot of fire suppression, even though they should burn. I think that's a problem too, where things, in a way, we force them to overgrow because we didn't. We extinguish all the fire, so like, oh, maybe a little fire. But little fire should happen, right? Like it help regulate things. I think that when it becomes the problem, and also like the species in the forest too, in a way, is affected by human, like agriculture and all these pollens that have been spread around. It's not just natural occurring forests. Oh, it was natural occurring, but it's also tampered with by humans. So, well, even though I don't know to what degree it's tampered with, right? There might be some species that usually you don't find as a majority, or start having different species that come in just from agriculture. But I don't know as to what degree that effect became prominent.
I mean, a great example of an invasive species in British Columbia is the pine beetle. So this beetle came over from across the Pacific. BC has Vancouver, which is a very large shipping port. But at some point, this pine beetle got in, and it had no natural predators, so it just completely infested BC forests filled with pine trees, and it killed these trees. These trees were dead but still standing, and that created perfect fuel for forest fires. So we saw much worse forest fires and more frequent forest fires in British Columbia because of the invasive pine beetle. So there are definitely some very negative effects from having species there that don't belong. And that's just an example of a species that's a bug. But there are other cases of different plants or even different animals coming in that can greatly affect a forest.
Yes, he has a very pessimistic view on humans. You talk about beetles, like, oh, because they flourish so well in this forest that they don't belong. It's like, oh, when humans move to a new place, flourish so well in a place that weren't there, and and destroy everything. Like, wait, that sounds like humans.
We are the Beatles.
Yeah, we're the beetles of Earth.
But it's crazy how much just Canada alone spends on fire suppression and firefighting. So from my current employer, which is the Department of Natural Resources Canada, and more specifically the Canadian Forestry Service, we spend between $500 million and $1 billion each year on just firefighting and fire suppression. That is an insane number. And we'll only likely see this go up as we see longer and more severe droughts happening. And yeah, just for some other numbers, in terms of the area that's burned, in Canada, I work with a great group. So it's a climate change group at the department, or the Canadian Forestry Service. And there's a group that works on the national burn area coverage of Canada. So each year they look at the previous year and see how much area was burned. And on average, it's about 2.3 million hectares a year, which is 23,000 square kilometers, or about half the size of Nova Scotia or the size of the country of Djibouti. So that's quite a large area. And again, that's going up. I think the largest one was about 7.6 million hectares. So more than the size of Nova Scotia.
And it's increasing, you say, because of probably global warming and humanity. One thing you said was we spend about $500 million to $1 billion. Was it a year on fire suppression and prevention and that kind of stuff? So I had to kind of ground myself in Google. I needed a reference point, so I Googled the U.S. military defense budget for 2021, and well, that's the first one that came up. So that was $800 billion. So we're spending about 1/800th or 1,600th of the U.S. defense budget on fire prevention. I always Google things. I always like reference points, even if they're really absurd reference points. It's like you see those photos of like, this is how big an elephant is. Here's a banana for scale. It's like kind of silly.
Oh, one word that Patrick mentioned was hectare. I don't think for people who don't know, hectare is a unit of area. It's equivalent to 10,000 square meters. And yeah, it's spelled like hectare. Hectare. I think pronounced hectare. So it's, to me, at first I thought it's pronounced hectare too. Like, oh, hectare. And for those more in American units, 2,471 acres. So it's pretty large.
That's 2.47 acres per hectare.
Oh, sorry, not 2,000. Yeah, 2.4.
Yeah.
I got dot and comma confused, but yeah, 10,000 square meters.
So yeah, it's a very large amount, and that's just in Canada. Not talking about other areas. I know Turkey had very severe fires last year. Brazil always seems to have wildfires in the Amazon. And these are particular places, especially Brazil, where you have rainforest that's undergoing droughts due to either climate change, we're seeing a lot higher temperatures and so differing weather, or land use cover change. So we're seeing a lot more development, especially of monocultures that are used for agriculture, like palm trees. So we're seeing a lot more of these areas that are not used to wildfires, like rainforests in Brazil, that are now subject to them, and it's just completely wiping out very large areas. So it will be interesting to see how this summer goes, because we're currently entering an El Nino phase of the ENSO, the El Nino Southern Oscillation, which is a atmospheric and oceanic occurrence. But essentially, El Nino means that we'll see warmer temperatures, and warmer temperatures will most likely mean more droughts, which means more forest fires. And we're already seeing record numbers in Nova Scotia and Canada and other areas of the world that are subject to forest fires and other types of wildfires.
Doesn't El Nino mean like the young boy or the little boy in Spanish? I Googled it and it says it means the Christ child.
Yeah, so it's more so having to do with the Christ child, just because when it was first kind of noticed or first recorded, it was around Christmas.
Oh, okay. Makes sense.
Yeah, so El Nino does mean the boy in Spanish, but in this case it means the Christ, but it's now the El Nino La Nina, which is the girl, oscillation.
Interesting. that's relevant because I'm using Duolingo to try and learn some Spanish. So I learned that recently.
See.
Anyway.
But we will have to get someone on who knows more about the Enzo, and everything that goes on with
I wonder
that.
if we get a firefighter on this at some point. That might be good. Because, I mean, if anyone knows the science of fighting fires, I'd say it's firefighters, right?
So there is a person who works in the same building as I do. I think she's currently working with Parks Canada temporarily, but her name is Amy Cardinal Christensen. And she has her own podcast called Good Fire, but she works for the Canadian Forest Service and apparently Parks Canada as well. She's a very strong proponent for cultural burns, but she is pretty much the expert in forest fires. So might be worth reaching out at some point.
I agree.
But just as a final thought on forest fires, I mean, they're obviously happening. They are showing to get worse. There was some data showing that there were fewer total wildfires, but they were larger in area. So we are facing this huge issue. And they're also a kind of a feedback cycle where they can create their own weather, they can create their own wind, which will spread them, and then they can also create their own storms, which will produce lightning, which will produce further forest fires and wildfires. So overall, there's a lot of research going into this and how we can better prevent them, and a lot of work with different cultures and different past experiences to understand how we can better manage forests and reduce fuel loads while being kind to nature. But overall, it is said that only you can prevent forest fires, but truly it's a group effort.
All right. Thank you, Patrick, for our main topic for today. And before we move on to story, Patrick will tell us about how to reach us and contact us on the podcast. And our story today, actually, we start this episode from the ground, like deep under the glacial, and we talk about the fire, and the story gonna be in the cloud. So it's pretty neat.
Well, before we get into a riveting sky-high story, I just want to tell you how you can contact us. So whether you are a professional forest fighter or forest scientist, or if you know more about the Enzo or ice cores, we would love to have you on the show. You can reach out to us in many different ways. The first of which is through our Gmail. We are hyperthesispodcast@gmail.com. You can send us an email. We check it pretty regularly. So if you're interested, reach out to us there. We are also on Instagram. You can find us at the Hyperthesis. We post updates about when we will be uploading episodes. We usually upload once a week. And we also post other updates. So feel free to send us a message there. Thank you again to Mr. Plow for sending us a message and giving us the idea for the story, which Liam was inspired by your suggestion. So thank you for reaching out. And if anyone else has any questions, suggestions, or comments, they can reach out to us on Instagram as well. We are on YouTube, so feel free to give us a follow, like, subscribe, whatever it is, and leave a comment. Our YouTube videos are painstakingly processed by Feely. Thank goodness for the new Mac chips. And we are also pretty much wherever you can find your podcasts. So we are based out of Spotify, but we're on Apple Podcasts, Google Podcasts, Amazon Music, and again, wherever you find your podcast. So feel free to give us a rating or subscribe to us. Reach out to us in any way that you'd like to. We're more than happy to receive feedback, or if you want to talk about your specific area of expertise, we would love to have you.
All right, Liam, take it away in your sky-high story.
Yeah, so like you said, we went from the ground up today. So now we're talking about clouds. Yeah, so this was a suggestion from Mr. Plow, Mr. Snowplow, I think.
Just
Mr. Plow, but he has a photo of a snowplow on his Instagram account. I feel like I got to make sure that's clear. But anyway, so his suggestion was he was interested to hear about cloud seeding, which is I'll talk about what that is, but it's actually kind of relate it to fires because it might be a potential way to fight fires in the future. Or maybe it's been done before, actually. I don't actually know. But anyway, so cloud seeding, what is it? It's a form of weather manipulation where humans can actually disperse certain substances into the air, which can either serve as nucleation points for cloud formation, or they can cause a sudden change in the cloud's temperature, causing it to rain or snow. So it's it basically you alter the microphysical processes that occur within a cloud, and I won't get into that because I don't know them very well. But this can allow for the creation of clouds, rain, and snow from scratch, and it can even be used to actually kind of control when precipitation occurs. So you can cause it to happen sooner, or you can cause it to actually be delayed. So I heard there's a company somewhere in France where if you pay them a crazy sum of money, they'll use cloud seeding to prevent rain for like an extra day in a specific region. So you can like book it for if you want an outdoor wedding, you can pay them to help prevent rain for your wedding day.
Oh, that's a little too much. Actually,
Yeah,
the
I agree.
cloud seeding has been used extensively in Thailand in the northeastern
Yeah,
part because it is known for its drought. So it's very dry and it's hard to grow things. So there's like a huge effort. I think at the time, cloud seeding was, it was invented in theory, but it wasn't done extensively at all, practically. So at the time, there was used a lot to actually induce rain because the region just wasn't it wasn't good enough water to to farm rice, for example. And now, like after cloud seedings, all this effort, this is like one of the best place to get rice, one of the highest quality rice in the country. So that's pretty impressive.
yeah. So I'll come to some applications of it in a moment in like some specific places, but Thailand's one of the big ones where it was kind of I don't want to say it was one of the first places where it was used, and apparently it was used successfully if it really increased the quality of rice that much. But researching this online, there's still a lot of scientists that debate its usefulness. It works we know for a fact. So let me talk about the history a little bit. So it was cloud seeding was first proposed in actually 1891 by Louis Gathman. I don't know who that is, but he proposed it. And he suggested shooting liquid carbon dioxide into rain clouds in order to cause water to condense and fall to Earth sooner. It was a little while before it was actually first experimentally verified in 1946 by Vincent Schaefer. I might have pronounced that last name wrong.
Schaefer.
Schaefer? Okay.
Yeah, it's like the fountain pen Schaefer.
Oh, actually? Okay. So Vincent Schaefer, and he actually was able to create snowfall by flying a plane above a specific cloud in western Massachusetts, and he dumped 2.5 kilograms of dry ice into the cloud, and this immediately caused precipitation, caused the water within the cloud to very quickly crystallize and fall towards the ground. And without his intervention, the cloud would have just, simply drifted through the sky and not rained or snowed. So cloud seeding, you can imagine controlling the weather is a pretty powerful thing. I remember as a kid, I had a little Nintendo DS video game where you were a mad scientist and you can control the weather and you could like create tornadoes and lightning storms and floods and droughts and famine. And it was pretty, you can imagine it's a very moral and legally gray area. So as far as I'm concerned, it's all right, Feely. Feely's showing me his Nintendo DS right now on camera with his
Actually, I bought it from our previous, not previous, like color. This is our guest, Grace.
Oh, you bought her Nintendo DS.
Yeah.
Incredible. But from what I can tell, cloud seeding is this kind of double-edged sword because on one hand, it has a great potential to help humanity, and it already has, like Feely was saying. Regions that are extremely dry due to global warming or drought or other things, you can basically make it rain, right? If you can stop famine, you can produce rain, which gives water to crops, which gives food to the people living there. Or you can even use it to help prevent flooding or induce flooding if you want to do that for some reason. But So you can save people's lives, you can save property damage, all kinds of stuff like that.
There's also specific conditions, though. The cloud has to be there, and so that must mean there's some kind of water around, right? Maybe because maybe the reason it doesn't rain, maybe because the clouds are carried to somewhere else. Let's say you are blocked in some kind of mountains, right? It maybe it won't rain there because the cloud just go over and just go rain somewhere else, rain in the ocean or rain in the lake where you don't live there. So it's not just you can just create rain anywhere. There are specific conditions, and once that met, we can manipulate it to a certain degree.
Mhm. You can use it to actually create clouds too, because as long as there's water vapor in the air, which there is everywhere, I mean, even if there's very little water vapor, there still is. You can fire little like dust particles in the air, and it'll cause nucleation, which we talked about before. It'll cause these little water molecules to all condense together and form a cloud. But I imagine that's pretty hard to actually, if you want to create a cloud to rain over a specific part of land. I feel like that's pretty hard to like predict where to create the cloud, when it will form, and when it'll to like steer a trajectory over some farmland. But I don't know the details of that. Maybe it's impossible. Maybe it's doable. But what I want to talk about is kind of the legal and moral implications of cloud seeding. It should governments and the extremely wealthy individuals be allowed to manipulate the weather at their will? Probably not, as far as I'm concerned. Again, it's like it can help people a lot, but also it could be very easily abused and misused.
Well, I mean, the thing is, right? Like the things in the air or things in the world are limited. It's well, you make it rain here, it won't rain somewhere else. If you prevent rain here, you like it's there are natural progression or things that are limited, right? Let's say there's a mountain. Let's say, well, you want to mine the entire mountain, right? Then that's gonna be different. So you have to be careful about environmental impact. Like, what about the farmers around who are waiting for rain, and there's specific time it's supposed to rain, and you change it, for example, for just like a wedding? Like, come on, right? So there's a lot of, I think, debate you can have.
Yeah, and that's one thing, right? Is that the Earth is a closed system. If you take something from somewhere, it has to come from somewhere. You can't just pull water vapor out of the vacuum of space, or maybe you can, but that's another topic. Um, so that's one problem actually. So China is a big user of cloud seeding, and they actually use it to help increase air quality in certain parts, which I don't quite know how that works, but there's a way to do it. One example is actually the 2008 Olympics, which were held in China. They used cloud seeding the days before leading up to it to prevent rain during it, which is kind of interesting. But there's some controversy because they use it in China. I forget exactly where, but there's like if you use it in one spot, the surrounding areas get affected, right? Because you take it from somewhere. If you use it to benefit one region, it actually hurts the regions around it sometimes. So there's actually like legal battles happening where like some farmlands are saying, "Hey, we're having very bad rain this year," because they're taking it all somehow. They're taking all the water vapor in the air through cloud seeding. And the other thing is legally, like if you create a cloud, it's kind of silly to talk about ownership of a cloud and this is my cloud and my water, right? Because you've paid a ton of money to seed this cloud, so now you're getting into like, okay, this is my cloud, but ownership of a cloud doesn't really make sense to me, at least. And then the final thing I want to say is that, well, weather is a very chaotic, unpredictable system. So cloud seeding could have very, very bad potential long-term effects on kind of our world's natural cycle and how things work.
I will just say Alberta does use cloud seeding. We use it quite often. And it's actually run by a non-profit group of insurance companies that try and prevent hailstorms. Because since we have the mountains right there, we have a lot of turbulence, which can lead to a lot of hail. But by cloud seeding, we essentially reduce the size of the hail through the use of silver iodide that's emitted by planes. And apparently it causes a lot less damage and it's proven effective.
Yeah, like
But who knows what the
Well, that's
effects
the
are.
thing, right? Like at first glance, cloud seeding is really nice. It's really good. It solves a lot of problems. But again, you're playing God, right? It might come back to bite you in the butt. Essentially, it's also cloud seeding. It's used everywhere. I was very surprised when I researched into this. It's like it's used all over the world all the time, and I've never heard anyone talk about it ever before. Like that we can control. Like I heard about it before being used in Dubai because that's a very dry place, so they were using it to create rain. But even in Canada and the States, some ski companies, so ski hills, they'll cloud seed to get more snow. Actually, right? Like that's pretty wild to think about. It's like it's an entertainment thing. It's not like we're saving people's lives by feeding them and watering their crops. It's like we're just doing it to have better ski hills. It's like that's kind of I don't know.
Well, yeah, I grew up hearing about cloud seeding all the time because yeah, it's used extensively to save people alive in a way, right? You to produce more food to do this, and it was one of the projects from there. Yeah. Anyways, it was one of the widely known project, and yeah,
Mhm.
so I think it's just culturally you just hear about what affects life more.
Yeah, I grew up somewhere that never had to really deal with that within my lifetime, at least. So it's something I never even heard about in Nova Scotia. I don't even know if they use it there. I mean, they might, but
To be fair, North American agriculture are like wheat, corn, stuff that like don't require that much water. But if you think about rice, right? It's paddy
mm,
fields. You need a lot of rain, you need a lot of water, and even like if it doesn't rain enough, then your rice die. But you think about corn, like it's you walk around corn fields, it's really dry.
yeah. So exactly, like that makes sense why like maybe I didn't hear of it growing up as much. Also, I'm just theoretical physics guy. Like I just stuffed my face in a book and haven't looked at the rest of the world for most of my life. So that's on me. But to wrap things up, cloud seeding, it's used in all these different countries. So like Thailand's a big one, India, Iran, Israel, United States, Canada, like all the big ones, Germany, France, UK, Russia, Australia, and China, to name a few. Um, the gist of it is that it seems to work, but there's still debate in the scientific community about whether it works and what would the long-term effects be. So I think we should probably spend a lot more effort researching it, both scientifically, legally, and morally, because again, playing God tends to be a tricky. It's you're walking on a thin ledge essentially. I'm of the mindset that maybe we shouldn't be trying to control the weather unless it's for very. We shouldn't be using it for ski hills. I feel like at the very least, it's one thing to like save people's lives. And one good application would be to fight fires. If there's a forest fire and you can just make it rain, that greatly helps fight the forest fire. And again, forest fires are natural; they need to happen sometimes. But if there's really out of control ones that are maybe man-made by accident and they're going to kill a lot of people, if you can use cloud seeding to create rain over that forest fire, you're going to solve a lot of problems potentially. So yeah, that's cloud seeding. Thanks to Mr. Plow for that suggestion. I think it's really interesting. And I wonder if they've used it in the past to fight fires. I don't actually know. They must have tried, right? It's such an obvious application to me.
Anyway, regardless, in the interest of time, we're gonna stop it here. Thank you, Liam, for the story. And I'll talk to you guys next week. Take care.
Bye, everyone.
See ya.